Hello, welcome to the first lecture of week 12. This is the last week of our course. In this week, we will explore asymptotes, different type of the asymptotes and the curve tracing in both Cartesian coordinates as well as the polar coordinates. So, the first lecture is totally based on the introduction to the asymptotes and some of the problems. So, what is asymptote? Consider a rectangular hyperbola, and rectangular hyperbola can be represented at xy equal to c, xy equal to c, where c is any constant which is greater than 0. And look at in the figure here, this is xy by c, xy equal to c here. The equation x by c implies y equal to c by x. So, xy can, this will give me y equal to c by x, right? And this implies that if x tends to infinity, I am looking for here, then y must be going to be 0, then y must be going to be 0. Now, modulus of y, this one, look at in the picture here, modulus of y is the distance of any point on this hyperbola from the x-axis, right? So, let us say we have a point P xy here, and from this distance, this is the modulus y. Similarly, you have a P here, P of xy. Then what is the distance? Distance is this one, that is the modulus of y, right? So, Pxy in the hyperbola from the x-axis. So, we can see that x tends to infinity or minus infinity. The distance of a point P xy on the hyperbola from the x-axis is going to be reduced. It's going to be, very equal to 0, right? And that means x-axis is a line which seems to merge with that hyperbola. So, looking for this one or looking for that one here, see here. So, if you are taking this, it's look like it seems that the x-axis is going to merge with the hyperbola, and that's what the lines are called the asymptotes. And we give the definition of asymptote mathematically here. A straight line, first of all, asymptote is a straight line. A straight line is said to be an asymptote to a curve if, as a point P moves to infinity, this point P moves to infinity, along the curve, the perpendicular distance from the straight line tends to 0. This is going to be 0. See, this is going to be much smaller, and it looks like at infinity it's going to be merged. So, that's what the definition is. It says that a straight line is said to be an asymptote for a curve if point P moves to the infinity, the distance between the straight line as well as the curve is going to be 0. And how many types of the asymptotes exist? There are several types of the asymptotes we have, but in general 3 types of the asymptotes are quite popular. The first one is vertical asymptote, and the second one is the horizontal asymptote, and third one is slant and oblique asymptote, right? So, that's what 3 types of the asymptotes we are going to read. In this lecture, we will explore first vertical asymptote and their mathematical conditions, and they are finding out for a given curve what will be the asymptotes. So, vertical asymptotes. Vertical asymptote, that means it is parallel to the y-axis and it is perpendicular to the x-axis, isn't it? It's a vertical one. And how we can define that one? That any curve which is close to at some point x equal to some constant and look like it's going to be 0, that will be give me the vertical asymptote. So, a line x equal to c, see here, x equal to c, this is x equal to c, is called a vertical asymptote to the curve of a function f. This is the function f, this is the function f. If fx tends to infinity, or any point at this curve p is going to be infinity or minus infinity as x approaches c from either side, this side or that side, right? In vertical asymptotes, we have used limits to describe the behavior of a function as x approaches to c. So, for a function fx equal to 1 by x minus 2, the vertical asymptote is what? How we can find out the infinity? Infinity, that means I have to find out denominator tends to 0, and how it tends to 0? If I tends to x equal to 2, so the asymptote become x equal to 2, a vertical line, right? So x equal to 2 will be our straight line, which is an asymptote for this function or this curve. Example 2. Now determine the vertical asymptote of a given function f by x square minus 4 divided by x square plus x minus 12. One of the most important way is to take this determinant is equal to 0, and that will give you almost the asymptote for required vertical asymptote for a required function, right? So before that you have to simplify the function first. Otherwise it may be possible that some of the function are numerator and denominator are cross each other, and then the vertical asymptote will be in a simplified form. So x square minus 4 can be written as x plus 2 into x minus 2 divided by x plus 4 into x minus 3, right? Now if x goes closer to closer from the left, the value of the function gets smaller and smaller negatively and approaching minus infinity, and x gets closer 3 from the right, the value of the function f gets larger and larger positively approaching plus infinity. So here is your graph of the curve, and as you can see here, x equal to 3, this line, and x equal to minus 4. So I mean, look at the structure here. I want to make this denominator as 0. How I can make this one? It is only possible if x tends to 3 or x tends to 4 minus 4, right? So that will be our asymptotes, and look at the structure. So as you can see here, this is the curve is going to be infinity, and this looks like x equal to 3 will be the merging point. So this will be an asymptote, this will be an asymptote x equal to 3. Similarly, x equal to minus 4 will be an asymptote, right? And as I had already told you that firstly you have to simplify your function or curve so that some of the terms are going to cross each other, and you will have the function in a very simplified form, and from that simplified form you can find out the asymptote quite easily by looking at denominator tends to 0. That will be your answer, right? This example is one of the good example where you need to simplify your function. So if I want to make this denominator tends to 0, I will do that. But before making this one, I have to simplify my function. And since the above one is x minus 1 into x plus 1 divided by x minus 1, so this denominator is cancel out, and the function has the very simplified version as x plus 1 only. So now which you are looking for to make a denominator 0, a denominator is nothing, denominator is 1, right? And this because, so that's why this function fx equal to x plus 1 does not have any asymptote, right? Now find the vertical asymptotes of y equal to log x square minus 3x minus 4. Log x square minus 3x minus 4. Now if you make log 0, right, that will give you an asymptotes, isn't it? Because y becomes the infinity now, y becomes the 0 now. So how I can make that one? So here x square minus 3x minus 4 is given. So I am putting this x square minus 3x minus 4 is equal to 0. And what will be the value? So as you can see here, x minus of 4 into x plus of 1, right? This is equal to 0. So x square minus 3x minus 4. And this will makes me x equal to minus 1 or x equal to 4. So x equal to 4 and x equal to minus 1 are the vertical asymptotes, because log of this 0, y equal to log of 0, will make me my asymptotes. This will give me the infinity, right? And see here, so this is x equal to 4, and the graph as one side, that means the below one is looks like it's going to be merging at x equal to 4. Similarly here they are merging each other x equal to -1. So the both points x equal to -1, a straight line, sorry, x equal to -1 and x equal to 4 will be our vertical asymptote for this function y equal to log x square minus 3x minus 4, right? So any log is given, just make this one as a 0 and you will get your vertical asymptote. Now look at for this one, for fx equal to 1 by x plus 1, f of x equal to 1 by x, and how I can make this denominator tends to 0? So that is only possible when x plus 1 equal to 0, x equal to -1. So x equal to -1 will be our vertical asymptote, and since limiting value of x tends to -1 of this function is nothing but infinity, right? So that's how I have derived the vertical asymptote for a given function. Similarly, for fx equal to 1 beta x plus 1 x minus 2, let us do that. So the function is given here 1 by x plus 1 into x minus 2, right? I have to make this denominator as 0, and this will give me x plus 1 into x minus 2 equal to 0, right? So this will give me either x equal to -1 or x equal to 2. These are the 2 points, these are the 2 straight lines. So the straight line, that means here x equal to -1 and x equal to 2, these 2 straight lines are our vertical asymptotes, right, for which fx approaches to infinity. Similarly, if I want to find out this one, we have put it this value x square minus 1, so this will be a cancel out, and when x equal to 1, we have 0 here, p of 1 equal to 0. So therefore x equal to 1 is not a vertical asymptote, however a hollow within the graph may exist, right? Similarly, fx equal to natural logarithm x minus 3. So if I want to find out the vertical asymptote, I make this ln x minus 3 f of x tends to infinity, and for that I make x minus 3 tends to 0. So this will give me x tends to 3. So x tends to 3 will be a vertical asymptote. So here we have x equal to 3 will be our vertical asymptote. This is the vertical asymptote for this function. Now look for that one, fx equal to f of x equal to 1 by x square minus 1. I can write this x square minus 1 tends to 0, right? So denominator becomes 0, that means the whole function tends to infinity. And for that x square minus 1 equal to 0, x will be plus minus 1, that is equal to x equal to minus 1 or x equal to plus 1, right? There are two lines, two straight lines, x equal to 1 or x equal to minus 1. Now check whether we have done our vertical asymptote or our claim for two straight line as a vertical asymptotes is true or not. And what will be the checking point? The checking point is if I x tends to -1, the whole curve or the function tends to infinity. That's our infinity or minus infinity, both are true. So let's just check this one. Limit of x tends to 1 minus left top side of this fx is x square minus 1, that will gives you from the left. So the value in the denominator becoming lower and lower, so this will going to be minus infinity. Similarly, if I put limit x tends to 1 plus and 1 by x square minus 1, this will be going to be plus infinity, right? Similarly, if I put limit x tends to -1 and 1 by x square minus 1 from the left. This will also give me minus infinity, and the limit of x tends to minus 1 from positive side, right hand side, 1 by x square minus 1 will give me plus infinity. So in the both straight lines and from right and left, the limit exists, limit tends to infinity, and henceforth the vertical asymptotes are true, and x equal to 1 as well as x equal to minus 1 will be our vertical asymptote. Now find the vertical asymptotes of 1 by x minus 2. 1 by x minus 2, the step 1, the function is already in the form of px by qx. That means the function is of the form of rational function. So what I have to do, I have to make this qx tends to 0 or qx equal to 0, and whatever the straight line it will give me, that straight line will be our asymptotes. So here look at in the denominator is x minus 2 equal to 0. So x going to be 2. So x equal to 2 will be our vertical asymptote. This is the straight line. And how we can ensure ourselves that x equal to 2 will be our vertical asymptotes. So the property of the vertical asymptote says that with the curve going to infinity, and the straight line which we claim the vertical asymptotes is going to be merging each other, right? So that means when x equal to 2 is here, so when I put the x tends to 2 from the left or from the right, the curve or the function, the given function must be going to the infinity. So now we are going to put that one. So finding out limit x tends to 2 from the left or from the right, and from the both, this is a very simple function. So f of x equal to limit of x tends to 2, 1 divided by x minus 2, and this will going to be infinity, right? So that's why it is going to be a vertical asymptote. X equal to 2 will be our vertical asymptote. Similarly, find the vertical asymptotes for a function fx equal to 3x square plus 1 divided by 25x square minus 36. So what I have to do, I have to make this denominator tends to 0. That's our first step, and that's our most critical point. And try to resolve this x in terms of straight lines. So what I will have here, 25x square minus 36 equal to 0. Henceforth x square is nothing but 36 by 25, and x is plus minus of 6 by 5. So there are two straight line, x equal to 6 by 5 and x equal to minus 6 by 5, right? And now I will check for both that this is our claim, these are the vertical asymptotes for this function. Now our claim, to verify that claim is true or hold for this function, I have to find out the limit x tends to 6 by 5 and this function. So putting this function, how much you will get? Limit of x tends to 6 by 5, and since here 3x square plus 1 divided by 25x square minus 36 is already given, right? So I will do that, like limit of x tends to 6 by 5, and make this one as 3 plus of 1 by x square divided by 25 minus 36 by x square, right? Finding the limiting point. And now put this value x to 6 by 5 here. This will comes out 3 plus of 25 by 36 divided by 25 minus 36 into 25 by 36. 36 cancel out, and taking limit x tends to 6 by 5, right? And this will give you 0, infinity, because this will be 0 here, so the whole function approaching to infinity. Similarly, if I put, since this is the x square quadratic function, so if I put minus 6 by 5, there is no differences and the whole function leads to infinity. And henceforth, I can assure ourselves that these two straight lines x equal to 6 by 5 and x equal to minus 6 by 5 will be our vertical asymptote for a given function. Now here find out vertical asymptote for a given curve fx equal to 5x square minus 4x plus 1. So I will do the same thing. Firstly, I have to equate this denominator tends to 0. So x square minus 5x plus 6 equal to 0. This will give me x equal to x minus 2 into x minus 3 equal to 0 and x equal to 2 or x equal to 3. Both these lines are asymptotes. The vertical asymptote, since x equal to something is a vertical asymptote, isn't it? It's a parallel to the y-axis. That's why it's a vertical asymptote. So that how we can sure that this will be our answer. So find the limits. The only one thing is that you need to find the limit. Put the value x equal to 2 here. This will makes you 0 and this will makes you infinity. Similarly, x equal to 3, this will makes you infinity. So that means with the straight lines x equal to 2 and x equal to 3, the whole curve going to be infinity, and henceforth this will be our required vertical asymptote. Here are some of the practice questions for you, and can we do for this one. So let me solve some of them, and then I will put for you as an assignment to do that. So first one, 1 by x minus 3. So fx is given here, right? And this fx, that means this is a rational fx. So this is a rational function in terms of px and qx. So what I have to do, I have to put qx tends to 0, and how I can check that the whole function fx tends to infinity as qx tends to 0, right? That is our limiting value. That is our procedure. So what is the qx? Qx is x minus 3. X minus 3 tends to 0. X tends to 3, right? Now if you put the x tends to 3, the curve is going to be infinity. So henceforth x equal to 3 will be our asymptotes, vertically asymptote. So this will be a vertical asymptote. Now look at in the question 2, x square minus 1 divided by x square minus 4. F of x is given. So firstly you have to simplify the equation so that denominator become in a simpler form, and with those simpler form you can find out your answer. So this can be written as x minus 1 into x plus 1 divided by x minus 2 into x plus 2, and there is no term to cross each other. Henceforth I have to equate the denominator equal to 0. So x minus 2 into x plus 2 is equal to 0. That will give me x equal to 2 or x equal to minus 2. So there are two asymptotes lines, x equal to 2, x equal to 2 here, x equal to minus 2 and x equal to 2 here. These two vertical lines which are parallel to a y-axis will become our vertical asymptotes. Similarly, can you find this one, right? Let us do this. X minus 2 divided by x square minus x minus 6, right? So how I can simplify it? Simplify the first one. How you can simplify this one? X minus 2 divided by x square minus of 3x minus of 2x plus of 2x minus 6, right? So you will take this as x minus 2 divided by x plus x minus of 3 and x plus 2, right? That will be your answer. And so here x equal to 3 or x equal to minus 2. That will be your vertical asymptotes, because the above one does not cut any another term in the denominator. Similarly, can you find this one, x cube minus 8 divided by x square minus 4? Making this will give you the same asymptotes. And what about the question 4? Question 4 is the greatest integer, a square root of the greatest integer where x minus 2 and divided by x minus 1 is provided. So go ahead and try to find out how we can make this one, the denominator, as equal to 0. Once you have a denominator equal to 0, the whole function is going to be infinity, right? And that will give your answer. So try to ponder over this question. I'm just left for you, and then you will understand that vertical asymptotes can be evaluated quite easily by using the denominator equal to 0, and by checking reverse back that the function points or the function itself or the curve itself at that denominator is going to be 0, it tends to infinity, and for that you need to take a limit with that vertical asymptotes x tends to that numbers. So I believe that vertical asymptotes has been a good impact on your calculus here. We will explore horizontal or x-axis parallel to the x-axis asymptote in the next lecture, as well as I will try to cover oblique or slant, we call it slant or oblique asymptotes, in the next lecture as well, right? Thank you so much.